One of the questions a lot of people ask is how did the animals spread all over the world from where the Ark landed? Part of the question stems from the claim by some that the area where the Ark landed was too wet and muddy, so people and animals were confined to the mountains of Ararat for a couple hundred years while everything dried out. This claim is an attempt to explain an ending of the flood coinciding with the laying down of the Cretaceous sediments in the Zuni megasequence. However, the Tejas megasequence lies on top of the Zuni and consists of marine rocks. So people taking the view of the flood post-flood boundary being at the top of the Zuni have to explain why there are more flood-deposited layers above it. Another part of this question comes mainly from critics of biblical creationism. They see the separation of the continents by vast oceans and ask how any of the animals could have gotten to other continents from where the Ark landed in the Middle East. Skeptics will often point out that the Bible isn't a science textbook, and they're right. Science textbooks are constantly changing as more discoveries are made and opinions and hypotheses change. The Bible is the unchanging word of the unchanging creator of the universe, and he can't lie. So we can be sure that what he says is the truth. This includes what he says about scientific issues. The Bible gives us the big picture. This big picture can help us to build scientific models to try to explain how past events may have happened and how those events have shaped the world we live in today. However, we don't want to hold to those models too tightly. Scripture is inerrant, but models created by sinful people may be proven wrong by future research. So do we have a Bible-based model to explain how animals got from the Ark to where they live today? Yes, we do. We're going to quickly skim over the events of the flood, and then we'll take a closer look at Genesis 8, verses 13 to 22, which gives the account of Noah, his family, and the animals leaving the ark. And we'll finish off by looking at how we know there was an ice age and how the ice age made it possible for people and animals to spread around the world within a few hundred years after the flood. In Genesis 6, God warns Noah about the coming judgment and gives him instructions to build an ark. Genesis 6:19 to 20 says, "And of every living thing, of all flesh, you shall bring two of every sort into the ark, to keep them alive with you. They shall be male and female. Of the birds after their kind, of animals after their kind, and of every creeping thing of the earth after its kind. Two of every kind will come to you to keep them alive." It's clear that representatives of all of the kinds of air-breathing land animals and birds are included. There were no fish or whales or other fully aquatic creatures on the ark. There was plenty of water for them outside. The word kinds refers to created kinds, or baramin, as some creationists call them. This means representatives of the cat kind, the dog kind, the bear kind, etc. Some people claim that Noah couldn't have gathered two of every kind of animal, so the flood account in the Bible can't be true. Well, look again. Noah didn't have to go searching for the animals. It says that the animals would come to him. God made that happen. In Genesis 7, the flood is initiated when the fountains of the great deep burst open. This is a geological event where the seafloor split open, releasing enormous amounts of subterranean water. This geological activity would have also been the beginning of tectonic plate movement and would have caused mega tsunamis that began to move the water onto the continent. If you doubt this, consider the 2004 Boxing Day tsunami in Southeast Asia. A section of the Sunda megathrust ruptured over a length of 1,300 kilometers and caused a tsunami with waves up to 30 meters high. According to Wikipedia, that tsunami killed roughly 250,000 people in 14 countries. Now imagine what would happen if every fault in the oceans did that at the same time. This is a Mercator projection of the whole globe. The oceans are generally dark blue, but there are lines of light blue. Those are mountain chains on the seafloor that extend all the way around the globe. It is believed those may show where the fountains of the deep broke up. The earthquake that caused the 2004 Boxing Day tsunami occurred approximately here. When the fountains of the deep broke up, subterranean water that had been under pressure in the rocks would have exploded out, followed by magma welling through the cracks that had opened. The water would have already been geothermally heated. When the magma rose and came into contact with the ocean water, the water would have flashed to steam, blasting huge jets of steam and water into the atmosphere, which would have then fallen as rain over the continents. The lava erupting from the mid-ocean ridges would have been hotter and less dense than the solid oceanic crust, causing it to sit higher on the mantle and raise the seafloor. This would have resulted in a sea level rise that helped to push the water up over the continents. Dr. Tim Clarey has been researching the sediment layers for a number of years, correlating the records from drilling cores across the continents, and he produced this chart to show the relationships between the different rock layers and the sea level rise during the flood. The column on the left shows the different divisions called systems of the fossil-bearing layers, and the column on the right shows which megasequences include those systems. A megasequence is a series of rock layers with an erosional layer at the top and bottom. The column in the middle of this chart shows the sea level inferred from the sediment deposited during the flood. The present sea level is marked near the right side of the column. As you can see, the flood rose up to day 40 when it launched the Ark and lifted it high above the ground. Then the waters prevailed, continuing to rise until the 150th day, when all of the high mountains were covered 15 cubits deep. If you try to interpret the text as a local flood, you get nonsense like this. Yes, there are still high mountains in the distance, too. If you're familiar with the fossil record, you know everything from the Precambrian up to the Devonian is marine creatures, fish and invertebrates. The Mississippian is the beginning of coastal flooding, where you start to see plants and animals from tropical coastal land ecosystems. From there, the pre-flood Pangea megacontinent began breaking up, and the sedimentation shows that the water continued to rise progressively and flood progressively more inland environments, going all the way up to the top of the Cretaceous system, where the flood peaked at day 150. Make a mental note of where the Neogene system and the Tejas megasequence are on this chart. We'll be referring back to them later. Psalm 104, verses 5 to 9 says, "You who laid the foundations of the earth so that it should not be moved forever, you covered it with the deep as with a garment. The waters stood above the mountains. At your rebuke they fled. At the voice of your thunder they hastened away. They went up over the mountains. They went down into the valleys, to the place which you founded for them. You have set a boundary that they may not pass over, that they may not return to cover the earth." This is poetry, but it describes a historical event, specifically the flood, in the form of a hymn rather than narrating it chronologically. This passage describes the mountains being uplifted, the ocean basins being deepened, and the floodwaters draining off the continents. According to the catastrophic plate tectonics model of the flood, the continental plates would have been moving substantially faster than they do today. As a result, they collided with each other, causing orogenic uplift or mountain building. Secular long-age models have difficulty explaining how modern velocities of the tectonic plates can produce enough force to create mountain ranges. These are a few different types of plate collisions. The rapid uplift of mountain ranges in combination with the cooling and sinking of the new oceanic crust facilitated the receding phase of the flood. The flood runoff produced a substantial amount of global fossil-bearing sediments, about 32.5%, that make up the Tejas megasequence. The Tejas contains a lot of carbonate rocks such as limestone and salt deposits. These rocks were deposited in a marine environment as the floodwaters receded off the continents. The Tejas entirely covers the Middle East, and the ark would have landed on top of it. Genesis 8:4 says, "Then the ark rested in the 7th month, the 17th day of the month, on the mountains of Ararat." So from this verse, we know that the ark landed somewhere in the mountainous areas of eastern Turkey and western Iran. So let's get into our scripture for this lesson. Genesis 8:13 says, "And it came to pass in the 601st year, in the 1st month, the 1st day of the month, the waters were dried up from off the earth, and Noah removed the covering of the ark, and looked, and behold, the face of the ground was dry." Before this, Noah had already sent out a raven and a dove to scout things out. He sent the dove out 3 times. The second time the dove brought him a fresh olive leaf, so he had evidence that plant life was recovering. But it obviously wasn't ready for masses of animals to come and eat it yet. Noah sent the dove out the last time on the 285th day after the start of the flood, and this time it didn't return. It can be assumed that the land was dry enough and the vegetation was reestablished enough to support some bird life. But Noah waited another 29 days before removing the covering of the ark, which was probably part of the roof. This verse talks about the 314th day since the flood began. So Noah and everyone else on the ark had been in there for a little more than 10 months. The Hebrew text indicates that Noah was probably happily surprised to see that the ground was dry, but he could also see that things weren't ready for everybody to leave the ark yet. It was probably still rather muddy, and it wouldn't make much sense to send the animals out where they might not be able to find enough food. Genesis 8:14 says, "And in the 2nd month, on the 7th and 20th day of the month, was the earth dried." So now it's been another 57 days since Noah removed the ark's covering, and he and his family and the animals have been in the ark for 371 days. Seeing the devastation from the flood, he probably wasn't about to make a move to leave the ark without God's say-so. This also gave more time for seeds on the land to germinate and grow. Rain after the flood probably would have helped to wash saltier flood water deeper into the subsurface so plants could grow more easily in the topsoil. Genesis 8:15-17 says, "Then God spoke to Noah, saying, Go out of the ark, you and your wife, and your sons wives with you. Bring out with you every living thing of all flesh that is with you, birds and cattle, and every creeping thing that creeps on the earth, so that they may abound on the earth, and be fruitful and multiply on the earth." Genesis portrays Noah as a man who walked with God and obeyed him. He didn't rely on his own reasoning. He built the ark when God told him to, entered it when God told him to, and now he receives the command from God to leave the ark. God doesn't just command that Noah bring out all of the animals. He also makes the statement that they may abound on the earth and be fruitful and multiply on the earth. This is a reiteration of what he commanded in Genesis 1. The people and animals are to reproduce and increase on the earth and repopulate it. There are 2 key points to note here. The creatures God brought to be saved on the ark had the innate capacity to dynamically adapt to a broad range of environmental conditions. God is the master engineer of all living systems. The creatures that were saved on the ark would have been representatives of all of the originally created kinds of land animals and birds. They would have had the highest reproduction potential possible. God wouldn't have brought giant sauropods to be saved on the ark that were at the end of their reproductive cycles. They would have brought smaller, younger ones at the beginning of their reproductive cycles so they could maximize their population growth. He also would have made sure that they had the maximum possible genetic variation. You can see this variation among the different kinds today, such as the horse kind, the cat kind, and the dog kind. Generally, we have many different species adapted to different environments. Among domesticated animals, we can see incredible diversity among one species in a kind, but that is usually a result of artificial selection. That's when people breed animals to amplify specific traits, resulting in a loss of genetic diversity within the different breeds. That's why purebred animals can be so expensive both to buy and to maintain. They often end up with health problems because of the limited genetic variability. God commanded the creatures to reproduce and be fruitful. This implies that he would personally make sure the global biological colonization of the post-flood world happens. As we'll discuss later, God made sure that the geologic and climatic conditions following the flood would allow for people and animals to disperse globally via intercontinental land bridges that formed during the Ice Age. Genesis 8, verses 18 to 19 says, "And Noah went out, and his sons, and his wife, and his sons' wives with him. Every animal, every creeping thing, every bird, and whatever creeps on the earth according to their families, went out of the ark." So we see that Noah obeyed God's command to leave the ark. He, his family, and the animals all left. I don't imagine that it would have been a chaotic stampede for the door. The passage says, according to their families, which implies that the animals left in an orderly manner. The Hebrew text uses a different word for kinds from what was used in Genesis 1. In this passage, the word used implies the reproductive fruitfulness of each kind of creature as it goes out to fill the different ecological niches, according to its capacity to diversify and adapt. Genesis 8:20 to 21 says, "Then Noah built an altar to the Lord, and took of every clean animal and of every clean bird, and offered burnt offerings on the altar. And the Lord smelled a soothing aroma. Then the Lord said in his heart, I will never again curse the ground for man's sake, although the imagination of man's heart is evil from his youth. Nor will I again destroy every living thing as I have done." The first thing Noah did after leaving the ark was to build an altar and offer whole burnt offerings to God. It can be said that these were not offerings for atonement for past sins, since the flood purged away human iniquities, but were the thanksgiving offerings to God for bringing Noah and his family safely through the trauma and destruction of God's judgment on the earth. However, because the passage mentions a soothing aroma, which is often used in relation to appeasing God's anger against sin, some view these offerings as a sacrifice on behalf of post-flood humanity, as well as an act of thanksgiving. This passage also illustrates God's grace in accepting Noah's sacrifice. He says in his heart that he will never again judge humankind through a universal catastrophe as he did with the flood. Genesis 8:22 says, "While the earth remains, seed time and harvest, cold and heat, winter and summer, and day and night shall not cease." So God promises not to destroy the earth with another global flood. He also promises that the seasonal cycle will continue until he destroys this earth with fire and replaces it with a new heaven and new earth. We don't know what the pre-flood climate was like, but we can infer from the longevity of pre-flood humans as recorded in the Bible and discoveries in the fossil record of apparent longevity of reptiles and other animals that conditions were more favorable for life. It's possible that this may have been because of a higher oxygen content in the atmosphere and maybe greater air pressure. It may also have been due in part to nutrition from plant kinds that became rare or extinct after the flood. God authorized the eating of meat after the flood. This may have been because human nutritional needs had not changed, but the sources of some nutrients had. Now recall that the Neogene system and Tejas megasequence were the last layers laid down by the flood. There are some thin sediment layers on top of the Tejas in various locations around the world that are called Pleistocene. Some of these might be late flood layers, but the majority were probably formed due to the unique post-flood climatic conditions. Now, what does that mean? How can climatic conditions produce sedimentary layers? Well, for one thing, the layers are typically made up of unsorted rock fragments. That means they look like very poorly sorted sediment on the left of this diagram. Lots of different sizes of particles. As rock fragments are transported, usually by water, they get bumped and chipped, and it wears down the sharp bits and makes them round. Faster water currents can carry larger particles, so as the water slows down, the heavier particles drop to the bottom. That's how they usually get sorted. There are other processes that can sort particles, but we won't get into that here. Pleistocene strata are also usually unstratified, which means they are made up of loose rocks and sediment that haven't been lithified or cemented together. In general, one of the defining features of Pleistocene strata is the global evidence of a post-flood ice age. There are a number of evidences for an ice age in Earth's past. These include mountain glaciers, continental ice sheets, drumlins, moraines, kettles, striations, and erratics. We'll go over what each of these are. This is a picture of a cirque. It's where there used to be a starting point of a glacier. Mountain glaciers form when massive amounts of snow accumulate on mountain tops. When summer temperatures aren't high enough to melt all of the ice, it continues to build up year after year. The weight of the snow and ice causes it to compact down, and then it eventually begins to flow downhill because of gravity. When some of it does melt, it can flow into cracks in the rock where it may freeze again. Because water expands when it freezes, this causes the rocks to crack further and break off bits. This is a process of weathering and erosion. As the glacier moves downslope, it scrapes away bits of rock which get incorporated into the ice. The glacier's movement works like sandpaper on the mountain, wearing down the rock. The result is sharp mountain peaks where the glacier began, and a U-shaped valley where it flowed down. Rivers form V-shaped valleys. Another piece of evidence of past mountain glaciers is hanging valleys and waterfalls like this one in Yosemite National Park in California. As the floodwaters retreated, catastrophic erosion scoured the uplifting mountains. Most of the sedimentary layers were removed by the retreating water, and the more resistant granite masses were exposed. Fractures in the granite influenced the direction of weathering and erosion. Heavy rainfall in the decades after the flood caused the granite to erode and weather quickly along fractures, forming valleys. During the post-flood ice age, heavy snowfall produced massive glaciers that moved down into the mountain valleys. Rock debris in the ice underneath and at the edges of the glaciers scoured the valley floors and sides, deepening the floor and cutting sheer walls. Today, the glaciers have melted, leaving behind beautiful tree-covered valleys surrounded by granite walls, and the tributaries have become hanging valleys with tumbling waterfalls. At the peak of the Ice Age, ice sheets covered almost a third of the land on Earth. The Laurentide ice sheet covered much of North America east of the Rocky Mountains, from the Canadian Arctic down to the state of Missouri. The Cordilleran ice sheet covered the land west of the Rockies. Other ice sheets covered Scandinavia and northern Asia and spread from Great Britain in the west to Moscow, Russia in the east. There are a number of geological signs that show the extent of these ice sheets in the past. The word drumlin is derived from a Gaelic word for a rounded hill. Drumlins are generally somewhat streamlined hills with a wider end and a narrower end. They usually occur in clusters with their narrow ends all pointing down ice, or the downstream direction of a glacier's movement. How drumlins form is still a mystery to scientists, mainly because nobody has been able to get under a glacier to observe their formation as it happens. One theory is that as the glacier flows, different strengths of materials are encountered. Stronger rocks are more difficult to erode, so the glacier is forced to move over and around them, scraping weaker material into the areas down ice of the obstruction. As glaciers move, they also push material ahead of them and out to the sides. Moraines form when the glacier later melts back or retreats. Lateral moraines form where rock and soil at the sides of the glacier get left behind. Ground moraines are made up of the sediment that is built up on the underside of the glacier. Terminal or end moraines show the farthest extent of a glacier before it retreated. Medial moraines form where two glaciers have merged and the lateral moraines between them join together and continue for some distance. Kettles form when a block of ice called a sérac detaches from the glacier. Eventually it becomes wholly or partially buried in sediment and slowly melts, leaving a pit. In many cases, water begins to fill the depression and forms a pond or lake, in other words, a kettle. Kettles can be feet or miles long, but they're usually shallow. Other glacial formations are kames and eskers. Kames are hills or mounds made of sand, gravel, and glacial till, otherwise known as dirt, that accumulates in a low spot on a glacier that is melting and retreating. When the glacier melts, all the sediment in and on top of it lands on the surface of the ground and creates a hill-like mound. Kames can be easy to identify because of what they're made of. They are generally sandy and rocky instead of being made up of the main soil type of the land they sit on. They are also usually just one mound on a flat ground instead of being part of rolling hills. An esker is a long winding ridge. It was created when a glacier left behind water and sediment as it retreated. Streams that flowed through tunnels below the ice left the sediment behind in long ridges like upside-down riverbeds. Eskers range from 16 to 1,600 feet high and 160 to 1,600 feet wide. They can be up to 10 miles long and are located where the original glacial river was. As glaciers flow over land, they pick up pieces of rock and sediment. These inclusions make the bottom of the glacier a kind of coarse sandpaper, capable of scratching the bedrock beneath. Over time, the glacier moves over rock and sediment, leaving striations on rock surfaces that can indicate the direction the glacier flowed. Glaciers can pick up big chunks of rock and transport them over long distances. When they drop these rocks, they are often far from the outcrop or bedrock they were plucked from. These rocks are known as glacial erratics. Erratics record the story of a glacier's travels. Looking for the bedrock units that correspond with erratics can reveal complex flow patterns. Erratics can be recognized because they are made from different kinds of rock from the area where they are found. This is a picture of the Okotoks Big Rock. It was originally part of a mountain formation in what is now Jasper National Park. During the Ice Age, a large rock slide crashed debris onto the surface of a glacier that occupied the present-day Athabasca River Valley. This debris, including the big rock, was carried out of the mountains on the surface of the glacier. As the ice melted and the glacier retreated to the mountains, the rocky debris, including the Okotoks Big Rock, was deposited across the prairies. Secular scientists have come up with dozens of theories for how an ice age could start. They usually have something to do with global cooling, but there's a problem. When everything gets cold, including the oceans, you get less evaporation, which means less precipitation over the continents. Less precipitation means you don't get the massive ice sheets we know were there. Creation scientists have developed an ice age model that flows out of the global flood. In this model, the ice age began about 200 years after the flood and would have only lasted for about 500 years. There are 4 points to this model. The first is hot oceans. During the flood, hot, molten material from Earth's interior erupted and produced an entirely new seafloor. This would have heated the oceans. Warm ocean water releases heat slowly and adds moisture to the air, which would have kept coastal regions relatively mild, even as the continents cooled. This ocean-to-land heat transfer would have reduced temperature extremes near the coasts, creating narrow belts of warmer, more stable coastal climates that could support human and animal migration. Evaporation from the warm oceans would have increased atmospheric moisture. As warm, moisture-laden air moved inland from the oceans, it would have been forced upward by cooler continental air masses and higher elevations. As the air rose, it cooled, causing the moisture to condense and fall as precipitation. In cooler mid to high latitude regions, this precipitation would have fallen mainly as snow, leading to rapid ice buildup. Aerosols are tiny solid or liquid particles suspended in the air, such as volcanic ash, dust, and sulfate droplets. Near the end of the flood and for some time afterward, there would have been enormous amounts of volcanism along subduction zones as the continents were moving around. This would have resulted in a significant amount of aerosols being released into the atmosphere, which would have reflected and scattered a significant amount of incoming light. This would have reduced the amount of solar energy reaching the surface, leading to cooler summers that allowed winter snow to persist and ice sheets to grow. Time is the last point. Everything needs time, but it doesn't mean that it needs millions or billions of years. This process would have only needed a few hundred years while the Earth equilibrated from the huge amount of plate tectonics that had occurred. Research into Earth's sedimentary layers and plate tectonics has shown that the pre-flood world likely had one large megacontinent. That megacontinent split apart to form the current continental configuration that we recognize today. The massive amounts of tectonic activity and new seafloor production don't just explain the heat model of the Ice Age. It also relates to how humans and animals were able to spread and repopulate the Earth after the flood. When you look at the separation between the continents now and the oceans between them, it can be hard to explain how people and animals could have dispersed all over the Earth after the flood. However, the problem disappears when you take the post-flood ice age into account. The amount of water stored in ice sheets during the ice age would have lowered sea levels by 350 to 400 feet below today's level. This would have created land bridges such as the Bering Land Bridge between Russia and Alaska. These land bridges would have been excellent pathways and migration routes for humans and animals to simply walk from one continent to another. One trail of evidence for animals traveling across land bridges is this cave painting of a marsupial in India. It looks like a kangaroo, and there were several similar paintings at the same location, but no kangaroos are living in India today. The archaeologist who originally examined these cave paintings thinks that maybe people from Australia must have migrated back to India at some point. However, another archaeologist who is an expert in Australian cave paintings says these were not drawn by Australians. It's a different style entirely. So what's going on there? Well, India is on the way from the mountains of Ararat to Australia. During the Ice Age, when the sea level was much lower, Asia and Australia would have been more connected by land bridges. How did the kangaroos get to Australia? They hopped most of the way. It's what they do. Where the ocean still blocked the way, they may have rafted across on floating vegetation mats left over from the flood. Why don't we find them anywhere else? Because the land bridges were only there for a few hundred years. As the Ice Age came to an end, the ice sheets melted, and sea levels rose and covered the land bridges. Another thing we notice about Ice Age animals is the large body size and thick insulating hair on the ones with the innate programming to live in the cold climates at higher latitudes. Mammoths, for example, were larger than other types of elephants, and they had a thick coat of hair and small ears for conserving body heat in cold climates. There's evidence that large herds of mammoths roamed across Siberia and North America and were hunted by post-flood humans for their meat and hides, and whatever else could be made from their body parts. We can see similar examples of larger variants of a created kind living in colder climates today. Polar bears are the largest of the bear kind today, just like the mammoth was the largest of the elephant kind. Admittedly, there are also smaller animals living in polar regions, as well as animals with little or no hair. Musk ox are not particularly big, but they are very well insulated by their thick, shaggy coats. Arctic hares and Arctic foxes grow thick fur too, and also have smaller ears than many others of their respective kinds living in warmer climates. However, walruses are enormous and have very little hair at all. Their insulation against the cold is a thick layer of blubber. These are all examples of the adaptive mechanisms God built into the genetic variation of the different created kinds. So, by starting with the presupposition that the Bible is true, we can see that it's possible to develop scientific models to explain what we see and how it may have gotten to be that way. People who disagree with biblical creationism use similar models in their evolutionary explanations of animal migrations, so there's no reason why we can't too. The fact that there are animals all over the world illustrates God's goodness, grace, and provision, as well as his intention for the animals to repopulate and fill the earth. As we wrap up, I want to point you to some excellent resources from the Creation Science Association of Alberta. The website is create.ab.ca. You can find a wide range of articles, books, DVDs, event information, and more. One resource I want to highlight is Head Start. You can find it by clicking the banner at the top of the web page. It's an online study tool designed especially for high school and post-secondary students. It explains key science terms and concepts that students encounter in biology, geology, and related fields, and it looks at them through a biblical and worldview-aware lens. It's very accessible and works well on phones and tablets. There is also a newsletter published 3 times a year called Creation Science Dialogue. It includes articles written at different levels, from introductory to more technical, so there's something there for students, educators, and anyone with an interest in science and faith. Finally, if you'd like to stay connected, you can sign up for the email list through the subscribe link on the home page. That's the best way to receive new dialogue issues, announcements about events, and other updates. Thank you for listening.